Next question is, you will have a probably experience your air popping while driving in the mountain. Why air pops? In plain area, the air pressure of air inside the air and outside remains the same as we feel comfortable. Now, if we drive a car mountains, the atmospheric pressure decreases at the stage of the pressure of air inside the air is higher than the outside of the pressure. So the air drum is stressed outside due to the height of inner pressure of the air. This high pressure air is pushed throughout out through a tube in the throat as a bubble popping sounds. As the reason of our air pop while driving in the mountains due to a escape of high pressure air form in the inner air region. Look at this one diagram, that air pressure now when we are going to be in a high, so that our air blocked when we go to the mountain. Now the next question is that if you fill an airtight balloon at the top of the mountain, will a balloon expand or contract as a descends the mountain? Explain. The balloon will contract when you fill a airtight it at the top of the mountain and then bring it down. Explanation that when you fill a balloon up at the mountains, its extended atmospheric pressure and the internal pressure on balloon will wall by the air balance each other as shown in the figure. Look at that you enter air inside the balloon, and when it's going to be it exert a pressure on the walls, but outside the atmospheric temperature also exerted a pressure inside the wall. So as we go down the mountain's atmospheric pressure increases, but internal pressure remains the same. This increase in atmospheric pressure causes the contraction of balloon. Next question is are both, look at this one balloon diagram now. Pressure inside and outside the air again in the balloon. Look at this, that all on the in every side of the wall, that inner pressure, inner air exert a pressure on the wall, and the outer, look at this one green one part, the outer air pressure is also exerted a pressure on the wall. So that's why it's in equal in magnitude. Look at this and look at this one diagram. Clear? So the next question is, our boat is floating on a swimming pool. When an anchor is dropped, will be a water level in the swimming pool increases or decreases, remains the same. So that answer is that when you put an anchor in the water, the pool's water level go down a bit. When the anchor in the boat, the water is displaced more due to the combined weight and the specific shape of the boat. When the anchor is dropped into the water, it sinks and displaces the water whose volume is equal to the volume of an anchor. The water displaced by the weight is more than the water displaced by the volume. So when the anchor is dropped in the water, the level of water is in the pool decreases. Look at this one diagram, that it's anchoring. This one is the anchoring, and this is the ship. This is the diagram of the anchor. It's going to sink in the water just because of their shape. Now, which material is more elastic, steel or rubber, and why? Steel is more elastic than rubber because steel comes back to its original shape faster than the rubber when the deforming force is removed. And other reason is that for the given stress, stretching force per unit area, strain is much smaller in the steel than the rubber, which will be increase in elasticity of the steel as compared to the rubber. Mathematically, elastic modules equals to stress by strain. We know that this formula, that so when you apply a stress on the rubber and steel, The rubber deforms more easily than steel. Then the deforming force is removed. Steel attains its original shape more quickly than rubber with an elastic limit. This is why we say that a steel is more elastic than the rubber. Look at this one diagram. This one is the rubber and this one is this steel that it's a more elastic as compared to the rubber. Thank you.